Friends, at SDSC Shah, we are celebrating the World Space Week 2022 from 4th October to 10th October. On these occasions, I would like to share some of our views. The theme for the World Space Week 2022 is space and sustainability. In this regard, I would like to share some of the views that we have and how do we go about the sustainability aspect with regard to space. The use of space for a multitude of applications is the norm of modern era. Owing to its stupendous success in terms of versatility and adaptability, space-based platforms are making inroads into newer frontiers. The use of space for sustainable future is being worked out by various spacefaring nations in a big way. The very basis of Indian space program has been to use space for the benefit of the common man. Hence, such an objective augurs well with the intention of making use of space for sustainability. In fact, all endeavors of ISRO are nothing but scientific pursuit to generate new applications on space-based platforms with a lot of common sense and a little bit of engineering. Through this, we are contributing towards global sustainability. In this regard, ISRO's space program has been put into 5 verticals. The first one is the space transportations, with which we have to make all launch vehicles and launch services. The space infrastructure, that is, we have to make spacecraft and satellites into and put it in the orbit, the desired orbits for the communication, navigation, Earth observation, space sciences and associated ground segments. With this, we have to develop another vertical, space applications, the DTH, ATM, weather monitoring, VSAT, natural resources management, agriculture, marine disaster navigation and e-governance. For sustaining all those things, we also have another vertical called capacity building, in which we look after the good ground infrastructure development, industry and academia interface, outreach and international cooperations, and to help whoever can develop applications. Then we are going into another vertical, that human space flight, developing capabilities to take humans to space and bring back, related hardware, enabling technologies and human rating, etc. In this regard, there is an interdependence of ISRO as a government organization with industry and academia. ISRO strives to provide a host of applications to the user, customer base, and these are driven by the dynamic space market factors, taking into the consideration getting help from the industries and the academia. Our country has unique challenges. Some of them are: India is the 7th largest country in terms of expanse. Population of the country is 1.34 billion. Around 64% of agricultural land is under dry areas. 65% of the population depend on agriculture as their livelihood. Over 7 lakh square kilometers is under forest cover. Only 4% of the world's water resources are available in India, declining per capita from the agricultural land. Also, we have problems with irregular natural distributions of water, low agricultural productivity of in dry lands. Water scarcity is more than 54% of the geographical area, and now we have to deal with low per capita income and irregular monsoons. The above aspects make sustainable development a major challenge in our country. The additional challenges for Indian scenario are, I can look at this like diversity, inequality, resources, and the scale and the magnitude of which development has to take place in our country. In this regard, space technology comes to the rescue in a multifaceted role. It adapts technologies such as digital elevation models, panchromatic cameras, multispectral imaging, hyperspectral imaging, high resolution, geographically distributed sensors, mobile data collections, positioning and navigation solutions. Some of them has to be adapted within a very short span of time. Data from the above is converted into an ortho image applying various modes, techniques and algorithms to generate specific products and applications to contribute towards water sustainability, food sustainability, disaster management, urban sustainability, governance and environmental sustainability. Here I would like to show that ISRO data products are contributing towards food sustainability, the water and urban sustainability, disaster management and environmental sustainability. Let us see how do we go about food sustainability in a simple way. We ensure or try to develop a method like the food sustainability to be ensured by various data products by having harvest estimates, wasteland maps, inventory of crops and pest monitoring. The satellite imageries contribute towards water sustainability. The imageries are used for groundwater recharge estimation, generation of surface water spread maps, groundwater potential maps, the estimation of the reservoir capacities. Towards environmental sustainability, ISRO has been in the forefront, contributing much in this area and related studies. Earth observation images from ISRO satellites are being utilized for natural resources census, estimate environmental effects of mining, forest cover assessment, categorizing vegetation types, bioprospecting and landscaping analysis. With regard to urban planning, the satellite images are used to ensure sustainable quality of urban life. The satellite images are being used in a big way under Amrut program of Government of India, Atal Rejuvenation and Urban Transformation. Satellite images are used to develop multi-layer maps to be used for multiple applications such as town planning, land use, drainage systems, greenery developments, waste management, urban transportations, water supply and so on. ISRO provides supports to the various agencies which takes care of the disaster management. We try to provide help in mitigation, preparedness, response and recovery of the disaster management. Here we provide satellite imageries and applications which will be useful in all phases of disaster management, and it is being widely used. ISRO has been supporting this management of disaster such as floods, landslide, cyclone, earthquake, forest fires, droughts, etc. Now we will look at education. Education is the main instrument that would lead to socio-economic development and long-term sustainability of any country. This is all the more relevant in a country like ours, where we have to reach the quality educations in inaccessible areas living in rural and far-fetched regions. Satellite technology can help overcome this obstacle by providing distance and region independent tele-education concept. Today, many villages in our country are linked to quality teaching faculty through satellites. This program has tremendous potential and scope for reaching the masses. With regards to medical, availability of basic medical facility to a large chunk of population is a challenge. The far-flung rural areas, inaccessible terrain and sheer distance are some of the obstacles that need to be overcome. In this direction, satellite-based telemedicine comes to the rescue. Many centers have established at village level and are up and running. Actually, telemedicine has helped people in faraway regions to interact and consult with the qualified doctors and specialists in urban centers. Through the NAVIC satellites, ISRO is providing an innovating message services which is proving very useful to all farmers throughout the coastal India. Fishermen, when in deep sea on board the fishing boats, can get information related to wave conditions, potential fishing zones, international boundaries, rough sea alerts, cyclone alerts, etc. This is possible through a NAVIC chip embedded in mobile phone. This service works through a simple Android-based app which has options of multiple Indian languages. Tracking of marine and terrestrial vehicles is made possible through Indian navigation satellites. This has been tested on marine vessels off the coast of Mumbai and has also been tested on fleet of metro buses in various cities. Accidents occurring at unmanned level crossings can be avoided using NAVIC satellites. To avoid this danger, a simple alert system can be installed at all unmanned levels crossing through a horn by the combination of a communication satellite and the navigation satellite through a navigation receiver fixed in the locomotive of every train. ISRO believes global sustainability can truly be achieved by a series of international cooperation initiatives as well as taking many bright ideas from various academia, startups and industries. Accordingly, ISRO has engaged with a number of countries and cooperative initiatives are being actively pursued with various stakeholders. ISRO is involved with the activities pertaining to climate change, activities related to space sciences, technology education and along with all the nations, and also have cooperations throughout the world in ground stations and etc. More than 250 agreements are in place and ISRO has engaged with close to 60 other countries. Now, as we develop, ISRO in collaborations with many industries and startups who have very good development model and application oriented programs to see how to bring it to a logical end so that sustainability can be met. Towards this, the way forward is in the next decade that what ISRO has to do or in the briefly is to enhance earth observation capability with a lot of payloads being developed by various agencies, advances in the exploratory missions, expand the ground station network, partnership in Gaganyaan program. Today, the sustainable development has been given the most significant importance at the global scale. UN in fact has indicated around 17 sustainable development goals and they are being shown here. Indian space program has been contributing towards fulfilling the sustainable development goals and we will like to classify the services to be offered or being offered as follows: natural resource conservation, monitoring climate change, international cooperation, community disaster resilience, capacity building, renewable energy. The following areas are the some of the trends in satellite technology of the future which are aimed at long term sustainabilities are being given here. The advent and use of high throughput satellite, explosion in terms of infotainment facilities, various endeavors related to human space exploration and human habitat in space, adoption of multifunctional systems in spacecraft, enhanced autonomy and fault tolerance of space systems, ultra low latency payloads, imaging under all weather and all times of the day, on orbit servicing to enhance life and better debris management, incorporate better stability and agility in satellites, more accurate positioning, navigation and timing services, use of electric propulsion systems, exploitation of commercial off the shelf technologies and small satellites, development and maintaining a robust ground segment, adapting some exotic materials and processes, generation and applications based on big data, some of the jargons like space data highways and inter-satellite data links, advancing the quantum technologies for secure communications. We have to embark on deep space exploration and harnessing newer frequency bands of electromagnetic spectrum and ensuring better revisit and repeativity aspects of Earth observation satellites. To conclude, some of the areas in which there is a need for immediate thrust is to whatever we are told to develop are satellite with higher throughput, space based multimedia and broadband applications, Earth observations with multi-band and high resolutions, economic, reliable and on-demand access to space, space-based digital solutions for common man, accurate climate and disaster forecast, high-tech cartography for planning of smart cities, effective natural resource management, and work out to out-exploit the potential of renewable energies. These are some of the things, areas in which ISRO is working and also trying to develop and try to get the cooperate with academia, industries, startups which has ideas and programs, and those who are able to develop the payloads through which we will ensure a very sustainability of the human civilization in our planet Earth. Thank you.